Hello viewers, I'm Kausalya. Today we are going to solve problems in exercise 13.1. Here the problem is a cubical block of side 7 centimeter is surmounted by a hemisphere. So here we are having a cube and a hemisphere, right? The side of the cube is 7 centimeter. Here a hemisphere is placed on the top of the cube, right? So what is the greatest diameter of the hemisphere? What is the greatest diameter the hemisphere can have? Find the surface area of the solid. So this problem is similar to the example problem number 2, right? So it's better to have a glance of example 2 problem, and then then you can view this problem because you will get a clear idea, right? So here the thing is, we have what is the greatest diameter, right? We have to find the diameter of the hemisphere which is mounted on the cube. So you see, the side of the cube is 7 centimeter, right? Similarly, you see the diameter of the hemisphere can be 7 because it connects these two sides, right? So here the length is 7 centimeter. Obviously the greatest diameter or the maximum value of diameter this hemisphere can have is 7 centimeter, right? Now we have to proceed with the surface area of the solid. So here we are having two different shapes. One is cube and another one is the hemisphere. So you have to find the surface area of cube as well as surface area of hemisphere. So here the one thing which you have to note is, you see, I am placing the hemisphere on the top of this cube, right? So when you place this, you see, this area, okay, that is the bottom area of the hemisphere, this occupies some portion, some area of this one side of this cube. Okay, can you accept this? Because you see, I am placing, again I am telling you simply, you see, let this be the top of the cube, right? So now I am placing this part here over like this, right? So what happens, you see? So this is that is for calculating the total surface area. Wait, I'll draw it somewhat bigger, you see. Let this be the one side of the cube, right? Now I am placing a hemisphere, okay? You just assume this one as a hemisphere, right? It is placed on the top of one side of the cube, or it is placed on the top of the cube. So now you are going to calculate the total surface area. So when you calculate the surface area, what happens, you see, the area covered by the base of this hemisphere, that is, you see, let this be the area which is covered by this hemisphere. So while calculating the total surface area, what the thing you have to keep it in mind, that is, you have to subtract this portion because this part is already covered by the hemisphere here. So we should not include this part while calculating the surface area of the cube, right? So here comes the formula, you see. The total surface area of the solid is, it is nothing but the total surface area of the cube plus CSA of the hemisphere minus area of the base of the hemisphere. I believe you people can understand, right, why we are subtracting the base? Because you see, this base, this base forms a part of the hemisphere, and while calculating the total surface area, we have to eliminate this part, right? Because this is this is a part of the hemisphere and we have to eliminate this because it occupies some part of this cube, right? So here the formula is, the surface area of the cube is 6a square and this curved surface area of hemisphere is 2 pi r square, and again you see the base of, that is the area covered by the base of the hemisphere is in the form of a circle. Okay, it will be in the form of a circle. So here what is the area of the circle? It is pi r square. So here we are subtracting this minus pi r square. So 2 pi r square minus pi r square is nothing but pi r square. Now just substitute the values. So the value of the side of the cube is 7, and as well as the radius of the hemisphere is also, the diameter is 7. Therefore the radius is 7 by 2, because you see this total length, right? This total length is 7 centimeter. So this 7 centimeter is nothing but this is the diameter. Therefore for finding the radius you have to divide it by 2. So here the value of the side of the cube is 7 and the value of r is 7 by 2. So just substitute the values, cancel out the common terms, right? And finally we are ending up with 294 plus 77 by 2. So 77 by 2 is nothing but this is 38.5. So finally here the total surface area is given by 332.5 centimeter square, right? So problem number 5, a hemispherical depression is cut out from one face of the cubical wooden block such that the diameter L of the hemisphere is equal to the edge of the cube. Determine the surface area of the remaining solid. So here the thing is, you see, again we are having a cube, right? We are having a cube and a hemisphere. Now the case is, you see, a hemisphere is cut out from one face of the cubical wooden block. So here we are having a cube, right? So here we are having a cube and a hemispherical part is, it is removed from this wooden block, right? So again you see the diameter L of the hemisphere. So to this hemisphere, right, L is the diameter of the hemisphere, right? Similarly, this is equal to the edge of the cube. So here the edge of the cube, it is nothing but it is the side of the cube, okay? All the sides of the cube, they are of the dimension L, right? So we have to find the surface area of the solid. So whenever you come across the word surface area, right? So here you see again we have to calculate the surface area of the hemisphere as well as surface area of the cube, right? So you see this problem is more or less similar to our previous problem, that is problem number 4, right? So for finding the total surface area, first we will calculate the values of radius, right? So the diameter of the hemisphere, it is L, which is equal to length of the cube, right? So radius of the hemisphere will be, it is L by 2. So radius of the hemisphere is L by 2 here, right? Now we are going to find the surface area. So as I told, we have to find the surface area of cube and surface area of hemisphere. And again you see here while calculating the surface area, this portion, okay, this portion of the hemisphere should be eliminated while calculating the surface area of the cube, right? So here the formula is, you see, curved surface area of the hemisphere plus total surface area of the cube minus area of the base of the hemisphere. Because you see this base area of the hemisphere, okay, this forms a part of this surface of the cube. Okay, this occupies some portion of the surface of this cube here, right? So here the thing is, you have to include the curved surface area of hemisphere and the cube, and you have to eliminate the area covered by the base of the hemisphere, right? Why? Because the reason is, this hemisphere, this occupies the surface area of the cone. Say yes or no. This occupies some surface area of the cone here. Therefore here we have to eliminate this. So the formula is, again you see, CSA of hemisphere is 2 pi r square and surface area of the cube is 6l square, and base of the hemisphere, it is in the form of a circle. So the area of the circle is pi r square, right? So just substitute the values. Again 2 pi r square minus pi r square becomes plus pi r square plus 6l square, and the value of r, it is nothing but L by 2. So just substitute the values here, and here you have to take the LCM. So 6 4s are 24. So pi L square plus 24 L square by 4. And here you have to take, you see, I'm having this L square common. So L square by 4 is common here. So when I take L square by 4 outside, the remaining terms are pi plus 24. So here this is the surface area of the solid. So here you see I am not mentioning any units because you see in problem nothing is mentioned here. They had simply told that the diameter is of L, right? No meter, none, no centimeters. So here we are finally ending our answer like this. It is L square by 4 into pi plus 24, right? So here again I forgot to tell one thing. You see, since we are removing this part, okay, removing this part of the hemisphere, right, 99% of the students will think you have to subtract, that is you have to find the curved surface area of the cube, right, and you have to find this area of hemisphere. You have to subtract the area of hemisphere from the area of the cube. No, that is not the thing. Again I am telling, here we are discussing only about the area, not about the volume, right? Only if we are supposed to calculate the volume, then we can do that, right? So here since we are discussing only about the area, here you have to find this curved surface area of the hemisphere as well as the curved surface area of the cone. And here the reason why I am subtracting this base area is because this base of the hemisphere, this occupies the one side of, this occupies some portion of the one side of the cube, right? That is the reason why we are subtracting this value, right? That's all. If you have any doubt, let me know in the comment section. Thank you.